Hi guys, we're going to be tackling another relative velocity problem today, and this time we're going to include center of mass into it. So this is going to be question 14 of your practice unit 3 exam. So if you have any trouble with these two concepts, please stay tuned. Particle A of mass 2 kilograms is moving at a speed of 21 meters per second toward particle B of mass 5 kilograms. Particle B is stationary. What are the velocities of A and B relative to the center of mass of the two particles? So we have our particle A and our particle B, and we know that particle A is moving 21 meters towards particle B. So as time increases, particle A is moving closer and closer to particle B. As for particle B, it's stationary, so it's going to be in the same position at every time point. So, as we can see, the distance between particle A and B over time will start decreasing. So how do we figure out what center of mass is? Well, according to our equation sheet, we know that the center of mass is equal to the summation of the product of the position times mass divided by the total of mass. We know that the mass of particle A is 2 kilograms, and we know that the mass of particle B is 5 kilograms. And from this equation alone, we should know that the center of mass will be closer to particle B than it should be to particle A. And this is because particle B is bigger and has a bigger impact of where the center of mass is. Now let's mark the center of masses onto our diagram. And like mentioned before, the center of mass should be marked closer to B than it is to A. And as shown by the diagram, as time progresses and A moves closer to B, the center of mass also starts shifting closer and closer to B as well. So overall, the center of mass can actually be treated like another particle, and we know that the center of mass is moving in the rightwards direction towards particle B. So how do we figure out what the velocity of center of mass is? The velocity of center of mass is equal to the summation of the product between the mass and its respective velocity divided by the total of mass. So plugging in our numbers, the velocity of center of mass is equal to 2 kilograms times 21 meters per second plus 5 kilograms times 0 meters per second because particle B is stationary. And we divide this by the total mass, which is 2 kilograms plus 5 kilograms. Overall, we get the velocity of center mass equal to 6 meters per second. So now we're going to talk about relative velocity, and this problem is very cool because it ties back to Unit 1. So the first part of the question is asking for the velocity of particle A relative to the center of mass. From your formula sheet, you should remember the formula. Velocity of A relative to C is equal to velocity of A relative to B plus velocity of B relative to C. So let's draw out our diagram. So we know that particle A is moving 21 meters per second towards particle B, and the center of mass is also moving towards particle B 6 meters per second. So, according to our equation, we're missing one more component. We need a third component to satisfy this equation. So this third component is going to be a person on the ground observing. So the third component is going to be ground. Now let's get back to it. So the velocity of A relative to the center of mass should equal to the velocity of A relative to the ground plus the velocity of the ground relative to the center of mass. The second component is equal to the negative velocity of the center of mass relative to the ground. So let's rewrite our equation, and we finally get the velocity of A relative to the ground minus the velocity of the center of mass relative to the ground. So that should equal 21 meters per second minus 6 meters per second, and that gives us 15 meters per second. So conceptually, what does this mean? This means that in the perspective of the center of mass, the particle A is moving 15 meters per second towards it. Let's apply the same exact concept to the next part, which is what is the velocity of B relative to the center of mass? So same equation, we're going to have the center of mass moving 6 meters per second towards particle B, and we're going to have B being stationary, so 0 meters per second. And of course, we're going to have the third component, which is the ground. So velocity of B relative to C is equal to the velocity of B relative to the ground plus the velocity of the ground relative to the center of mass. Again, we can rewrite this equation as such. So let's plug in our numbers, which should give us 0 meters per second minus 6 meters per second, which is equal to negative 6 meters per second. Once again, same concept. So according to the center of mass's perspective, the particle B is moving towards it, this time in the leftwards direction, 6 meters per second. I hope you all found this video to be helpful, and now having a better understanding of relative velocity and center of mass, I hope you guys can tackle question 1 of part 5 of your lab.